Welcome back, YouTube. This is the Death's Doorstep Devlog Part 4. Last week I focused on breaking up this standing state into multiple child states, such as walking and running, as well as ducking. This week I'm going to focus on how breaking up that state led me to create a little bit more advanced movement design. I wanted to have a little bit more range of motion allowed for the player within my game. Having more movement options leads to more player expression, which is something I really wanted to chase when designing my game. So I focused on that this week, and I'll give you a little bit of a summary right here as to what I added. So first and foremost, I added jump heights based on the current state that you're exiting. So if you're standing, you can only jump yay high. If you're walking, you can jump a little bit higher. If you're running, you can jump still a little bit higher. And then on top of that, you can, if you do a double jump, if you're thinking Mario 3D games, there is a double jump option. Not a triple jump, just a double jump. So if you mash the jump button just before you hit the ground, you do a little bit of a front flip, and you'll fly a little bit higher into the air, which will allow you to reach some nice high places. And you can double that with the glider, so you slowly float down to the ground. On top of that, I also polished up the existing spin animation. So it's no longer just a stickman spinning on the spot. It's actually a full-fledged animation, and you can jump out of that into the glider or a double jump. Oh, right off the camera. You can jump out of that into a double jump and keep the momentum going. So I'm going to dig into how all of that kind of pieces together through the use of my state model. If you haven't seen my state model before, I'm not going to be going in as much detail as I have in previous videos. You can check out my previous videos if you want to see the full detailed explanation of them, but for now I'm just going to cover what was added this week as compared to last week. So first and foremost, I like to separate the amount of jump power into a separate constants file. You can see I have my walk speed, my running speed, and my spin speed all defined up here in relation to each other. This just keeps my code a lot cleaner. I'm not having random constants defined all throughout my source code. It's all in one single place. If I want to speed up the walk speed maybe a little bit, I can just bump this number up. Same deal goes for the jump power. You can see the different jump powers for standing, walking, running, as well as when you're doing a flip. If I want to tweak any of these numbers, let's say I want to reduce the amount of height you would get off of a flip jump, I am able to do that. I like these numbers right now, though they're not finalized, and I may end up tweaking them in the future still. But when I do want to tweak them, they're all hosted in a nice little singleton file like this, so that they're easy to find and I don't have to look through all my code in order to adjust that. Actually implementing the different jump heights becomes dead simple once I start using that constants file. Right here you can see this is the standing state, and on a jump pressed event, just use the standing jump power. Same deal with a walking. Walking has a jump event as well, which just uses the walking height as well as the running height. The double jump flip is a little bit more involved, and there's a few more moving pieces that I can show you. It relies a little bit on the input buffer service, which I have not gone into depth for yet. So I'll show that real quick. The input buffer service just tracks the most recent button presses. So in this case, so far at this point, I have jump pressed and whip pressed defined. So when those buttons get hit, I track those to the most recent buffer record, which basically just tracks when those buttons were hit, when that button will expire, so if they'll time out eventually, I don't want to buffer them for too long, as well as if any of the directional inputs were held at the same time, in case I want to do something like an up attack or a down attack based on the button that was held alongside the whip button. In this case, I only care about showing off the jump press button because I want to be able to do a flip if the user presses jump just before hitting the ground. So jumping back to the jumping class, you can see the input buffer service is being used. It's listening for whip and jump events. And if I scroll down to here where I enter floor, so basically when you collide with the ground, it'll check the input buffer. So if the input buffer exists, it's valid, and the button was the jump button, then clear the input buffer, we're using it, so we don't want it to exist anymore. Oh, this is actually something I was commenting out just to debug. So I can comment that back in. I'll explain that in a second. So here we can check can flip. Can flip is basically what prevents the user from flipping over and over and over again. So I don't want you to be able to do a flip after a flip after a flip. So I can do one, but I can't do a second one. So there's a little break in between. You can get around that by doing a glider. So I can do a flip and then glide, and then do a flip and then glide. I don't mind that, but I didn't want you to be able to do a flip and then a flip and then a flip. It was kind of over too strong, like too powerful. So I put a limiter on there, and that's where can flip comes into handy. It's just a Boolean that flips on and off based on whether or not they've already flipped in this current jump cycle. Then on top of that, checks to make sure the jump button is still held. Just because there's a jump button in the buffer doesn't mean it's still being held. So only use it if the user managed to hold on to that jump button. If they released it, then don't do the jump. Otherwise, the user's going to end up flying into the air against their will, which I do not want. And then this just makes sure that they are moving. So you cannot do it from a dead stop. I think you saw me doing that there a second ago. You can see I can just do it from a dead stop. I actually don't want that. I want you to have some momentum in order to pull it off. So if I save this file, this will rebuild. And now you can see I can no longer do the double jump from an idle state. But if I'm moving, I'm still able to do it, which is precisely what I want. I turned that off just so I could debug the animation better. I was adjusting the animation to get the way I wanted. I can actually also show off the animations in Sprite, which is the editor that I use. I'll get to that later. So if all of these conditions hold true, then that means we are going to be doing a flip on landing and hitting the ground. So at which point we will set the flip flag to false so that we can't do sequential flips, as well as we'll play the animation and jump back into the air with the flip power. We'll never actually leave the jumping state here, so we'll be staying in the jumping state. We're just launching ourselves back into the air. So that's how we know can flip will remain false. If I'm correct, can flip enters true as soon as we enter this state. So every time you enter the jumping state, you can do a flip. But once you've used the flip once, then you have to wait until you hit the ground again, which is this case. So if you didn't do a flip upon hitting the ground, then allow the player to do another flip again. Play the normal jumping animation, not the flip animation. And then this is just setting the jump height based on standing, walking, or if they've already released the jump button. If they've already released the jump button, we only want to give them a little jump, basically. We don't want to send them flying into the air. So that covers the flipping logic. There's a little bit more to it, as you can tell from just the walking and running variable jump heights. Last but not least, I'm going to touch on the spin animation. If you've ever played Donkey Kong Country, you may be aware of the roll jumping mechanic, which is something that I am basically just using. I love the Donkey Kong Country games. I've always loved roll jumping. It's just very freeing to know that you can just jump off a cliff and save yourself if you do it properly. So as you can see, the spin jump there allows me to jump mid-animation. So I can just give myself a little bit of extra speed and distance on a jump. Oh, I missed that jump horribly. But doing that, I can dodge some... I haven't actually put any walls above me in this map, but I can grab things below the platforms if I time my jumps properly. It's just a very fast-paced mechanic. Also, the spinning has its own speed, so you can tell that I'm walking, I can speed up a little bit by running, I can speed up a lot a bit by doing a spin. So one thing that I want to point out is that the speed that you begin your jump with is the speed that you'll end your jump with. So if I'm walking and then I jump, even if I hold the run button, I won't pick up speed. So I can jump, hold the run button, and I won't speed up until I hit the ground. Same goes for spinning. So if I run and then I do a spin and then jump, I'll maintain that spinning speed. So once I'm airborne, I can keep that spinning speed. So knowing that, I can actually maintain my speed from a spin by doing flips and gliding. So in this case, I can do a spin, jump, do a flip, and I'm still gliding at the speed of the spin. And you can see how much distance I can travel using that. I'm really big on speed running mechanics. I like to speed run myself. So having this option was a really big thing for me, even to just enjoy playing my own game. And I can maintain that speed for quite a distance. So I can just kind of keep doing jumps, if I can actually land the jump, that is. So I could fly through this whole room by maintaining a single speed. So I can spin once and then just do some jumps and then maintain that speed as I go. So I've only done the one spin, but I'm maintaining that speed throughout just by doing flips and getting some height again. So I'm actually going to finish off this week's video by showing off the animations that I made this week. I tend to focus on the actual coding aspect of my game when doing these vlogs, but I spend a lot of time actually creating animations. I'm a developer by trade, but I've actually just kind of been learning animation over time, so it takes me a lot longer to do these things as opposed to actually just coding and throwing the code together. So you can see I created a flip animation. This one's just simple. I wanted to have another variable. I wanted to have another option to the jump animation, since this one's pretty bland as far as like, oh, I pulled off a move. I want some sort of like nice feeling if you're pulling off like maybe a higher jump, in this case a flip. So I went with the flip. Seems to work pretty well. And then when you're done the flip, you'll end up back into the fall state as well, which is used alongside the jump state. Once you start losing momentum vertically, you'll fall into the falling state. And then on top of that, the one that took me the most time to finish was the whip run animation. So you can see this one's kind of split into like 3 different portions. So there's whip run A, whip run B, and whip run C. Whip run A is simply the beginning, so winding up. Whip run B is when you actually spin, which is when you actually are able to jump out of it. Whip run A and whip run C are beginning and end. So whip run C is when you exit the animation. Just a little bit of a transition state. This I actually loop in game. So if I open up Sublime, you can see there's this variable called iterations. And when you enter the state, iterations is 0. It'll begin whip A. Once A is done, it'll go into whip B. Whip B is where we're looping over and over again. So when you do whip B, you play the animation speed, and then when whip B ends, you do loop whip B, which is basically just checking this iterations integer. And it does multiple iterations of the same animation for as long as I feel like doing them. And then if there's more iterations to do, then jump back to the beginning of the animation. Otherwise, then jump to the exit state. So if I bumped this value to like 20, this whip would like never end. So let's play this real quick. So if I do a whip knowing that, it's just going to go and go and go and go and go. This is simply because I only wanted to create 2 frames for this animation. It covers the general idea pretty well. It just looks like a very quick spin with some blur frames. And it happens very quickly when you're actually playing the game. So I didn't want to spend too much time actually creating multiple frames for that. So I just looped the existing frames over and over again. Because when you do that in real time, you barely even notice what's happening. And there we go. There's a normal length of whip. Just a quick spin and then fall back out to the last C animation. And that's all I have to show off for this week. Next week I'm going to be building a few more advanced movement options. I really got into doing these ones specifically. They made my game a lot more fun to test play. And as much as I really want to get into moving levels or creating levels, I also want to make sure I have the basic movement down before I do so. Some of the things I might put off until later just so I can actually start getting a demo ready. But some things I also just really want to get out of the way sooner rather than later. So you'll see the next video. I'll show off some of the other things I've been working on. I have a few more other things in the go still, so I haven't showed those things off yet, but we'll get to that. So until next time, see you later.